Welcome to my assembly instructions for the Thermatron Michigan Mighty Mite power supply kit. If there's anything you don't understand in these instructions, please email me. Happy to help. This is a very simple high voltage supply using a transformer that supplies around 120 volts AC and 6.3 volts AC. These voltages are dependent on the line voltage in your area and are based on a 115 volt line voltage input, which is low in most areas of the U.S. The high voltage is bridge rectified and filtered to produce around 190 volts DC. And again, that depends on your local line voltage. The transformer can supply about 93 mils, plenty for Thermatron work. And a 27K bleeder resistor helps stabilize the supply and bleeds off high voltage when you turn it off. An LED is attached across the filament supply to indicate the supply is on. Warning! This kit contains high voltage, 120 volts AC and 190 volts DC, which could cause a nasty shock. Now, I've tried to make it difficult to come in contact with the power line voltage and the high voltage DC, but it's possible if you want to touch high voltage locations while the power supply is on. Don't. All right, follow these simple rules. Don't touch any part of that supply when the dang thing is on, okay? If you need to move it or connect or disconnect anything to it, unplug it. Don't just turn the power switch off. You'll easily forget if it's on or off. When you turn the power supply off, give it at least 5 seconds for the high voltage capacitor to discharge before you touch anything. The lead turns off instantly, but the high voltage has to discharge through the bleeder resistor, and that takes about 5 seconds. This is what the supply looks like when completed. It's designed to supply power to the Thermatron Michigan Mighty Mite and future Holoskate Designs kits. It's built on a 3 1/4 by 4 1/2 inch copper-clad board. Construction is similar to the Thermatron Michigan Mighty Mite. Everything is soldered or glued to the board. There are only 6 components, and the layout is not critical. There is a plexiglass cover to help prevent you accidentally touching anything when the power supply is on. I used insulated, spring-loaded connectors to connect the power supply to the line voltage and the Thermatron Michigan Mighty Mite or any other Holoskate design kits. This diagram shows the recommended locations for all the components. The transformer label indicates what color wire is what. Green is the 6.3 volt AC. Red's the high voltage and connects directly to the bridge rectifier. The orientation of the bridge, by the way, is critical. Make sure the transformer high voltage connects to the AC bridge terminals. Refer to the diagram to see where things go. I recommend mounting the transformer first with the provided number 6 screws and nuts, even if it's just temporarily. Next, glue one of the spring-loaded connectors about where it's shown in the photo. Cut the black leads out of the transformer to a convenient length for connection to the spring-loaded connector. We'll come back to this side shortly. The bridge rectifier leads are labeled on top, the 2 AC inputs and the plus and minus output. The plus lead has the corner flattened. Bend the leads out like this, leaving about a 1/4 inch before the bend. Then cut off the leads, leaving about a 1/4 inch to solder. Start on the output side by gluing down the pads. Temporarily place the bridge where you want it. I temporarily put the other connectors on the board just to make sure where parts are going to go. I put a mark on the board where the pads for the bridge are going to go. Glue down the 3 pads for the bridge. The negative bridge lead is soldered directly to the board. Add an extra pad for the bleeder resistor. Next, glue down the pads for the LED and its associated resistor. Before soldering the bridge down, measure and mark how long the red leads from the transformer need to be. Each red lead goes to an AC pad of the bridge. It doesn't matter which red wire goes to which AC terminal. I routed one of the red leads under the bridge. This isn't a requirement. You can route it on the outside of the bridge if that's easier for you. Then cut the high voltage leads to the right length, and then the green filament leads. I removed the transformer to make this step easier. Once cut to the right length, strip about 1/4 inch of insulation off each lead. The leftover wire can be used to make the short jumpers on the board. Then tin each lead. This makes soldering to the pads way easier. Back on the board, go ahead and mount the bridge rectifier. Make sure the negative lead gets soldered to ground. This will hold the bridge in place. Don't solder the other leads just yet. This is also a good time to remount the transformer. Solder the red lead to the AC bridge pad. I found this is a lot easier if I held the wire in place with a flat blade screwdriver, left, or needle nose plier, right. Dealing with the transformer wires is a bit tricky since they don't want to stay where you put them. Next, I routed the other red high voltage lead under the bridge to the other AC bridge terminal. This turned out to be a little tricky to hold the wire in place during soldering. So feel free to route the wire around the outside of the bridge if that works for you. You can also super glue the wire to the board to hold it in place before soldering. Next, install the bleeder resistor next to the bridge. Keep it in place by soldering one end to the ground first. The other end will be soldered when the filter cap is installed. Next, install a short length of wire, tinned at both ends, first to the positive bridge pad. The other end will later go into the B+ spring-loaded connector. Next, cut and bend the leads of the filter capacitor as shown. The negative side lead will get soldered to ground. The positive lead will get soldered to the plus bridge and bleeder pads. Now, some manufacturers mark the negative lead, some mark the positive lead, but make sure you can identify which is which. Solder the negative lead to ground first, since this will hold it in place. Solder the positive lead to both pads, joining the two pads together. Next, install the LED and limiting resistor R2. Bend the leads of the LED as shown. It doesn't matter which way you install it. First, solder to the pad in the middle to hold them both in place while you solder the wires on the other leads. The photo shows how I did it. Now is a good time to install the spring-loaded connectors. Install the filament voltage connector first. I made 2 short lengths of hookup wire and stuck it in the connector prior to gluing it down. The wire is just the right length to line up with the pads. Pretty clever, huh? Now hold the green filament wires in place on each pad and melt the solder to secure them. Again, a little tricky since the filament wires don't want to hold still. With the filament side done, time to finish the high voltage side. I pre-installed a short length of bare wire on the ground side of the connector to make it easier to solder to the board when installed. Glue the other connector to the board next to the filament connector. When it's dry, solder the bare wire to the board. Take the short red wire you installed earlier and insert it into the B+ side of the high voltage connector. That completes this side of the supply. Now check to make sure the wires inserted into the connectors are making good contact and aren't loose. Use an ohm meter to make sure there's a good connection. Back to the line voltage side. Insert both transformer wires in one side of the spring-loaded connector. Now make sure they're firmly inserted. You should not be able to easily pull them out. Next, split the line cord back about 2 inches and strip off about 3/8 of an inch of insulation and tin the wire. Insert the line cord ends into the connector. When you install the plexiglass cover hardware, you'll install the strain relief over the line cord. Do not forget this step. Before you install the plexiglass cover, you should test the supply to make sure all is working. Place the board on a non-conductive surface and attach a voltmeter between ground and the B+ connector. When you turn it on, 2 things should happen. 1, the LED should light. Second, you should register high voltage around 180 to 190 volts. Your voltage will depend on your local utility AC voltage. Mine's about 122 volts. Then check the filament voltage. Mine reads about 7.76 volts, which is high due to my high line voltage and the fact that it's not connected to anything. When connected to the 6C4, it drops to about 7 to 7.1 volts. This is okay for typical 6.3 volt filaments. I don't think you're going to push usage of the Thermatron to 5,000 hours. If everything is working okay, now it's time to install the plexiglass cover. Insert the 4 2.5 inch number 6 screws into the 4 corners. Make sure you install the line cord strain relief on the line cord. Each screw gets 2 of the nylon standoffs as shown. Then remove the protective cover on the plexiglass and install it on the screws. Try a couple of different orientations to get the best fit. Now the board and the glass were drilled together, so one orientation should line up perfect. Then put on the 4 washers and nuts. Do not over tighten them or you'll crack the plexiglass. There are 2 labels provided. I highly recommend you install them since it's easy over time to forget which connector terminal is what. It's also a good reminder that there is high voltage on the board. Congratulations! You now have a working high voltage power supply. I used 4 short jumper wires to connect it to the Thermatron Michigan Mighty Mite. It can also be used for your other homebrew Thermatron projects. Just remember, make sure it's unplugged before making connections. The end. Don't forget, if you got any questions, don't hesitate to email me. 73 from KJ7 Uncle Mike.